Welcome to Two Projects. In this video, we are going to explain the project DOS detection to classify traffic flows as benign and malicious using deep learning. Before diving into the execution, let me give you an overview of the project. So, a denial of service, that is DOS attack, aims to make a network service unavailable by overwhelming it with excessive requests or data, disrupting normal operations and preventing legitimate users from accessing the service. So these attacks can slow down or crash the server, making it inaccessible to regular users. Detecting these attacks is very important for maintaining network integrity and performance. But traditional methods like signature based methods and rule based systems often fail to detect new or evolving attack patterns, which is why this project proposes using deep learning models to improve detection accuracy and reliability. So, the workflow includes importing necessary data, performing exploratory data analysis, that is EDA, visualizing the data to understand the distribution of the data, splitting the dataset into training and testing sets, and building and training both ANN and LSTM models. And we compare the models using metrics such as accuracy, precision, recall, and F1 score to select the best performing one among them. So, this is what happens in this project. And the project benefits network administration by improving their ability to detect and mitigate DOS attacks, organizations by enhancing network reliability and security, and end users by providing safer and more trustworthy network services. So, the primary goal is to enhance network security, minimize DOS attack impacts, and ensure continuous service availability. Now we look at the software and hardware requirements. So, hardware requirements to execute this project are operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Software requirements are application needed is Anaconda, primary language required is Python, front-end framework needed is Flask, backend framework required is Jupyter Notebook, database needed is SQLite 3, and front-end technologies required are HTML, CSS, JavaScript, and Bootstrap 4. Now we'll look at the algorithms built. So as I mentioned earlier, we have built ANN, that is artificial neural network, and LSTM, that is long short-term memory in this project. And we have compared the performances of these models using accuracy, precision, recall, F1 score, and other metrics. And we have observed that ANN has outperformed LSTM in all the performance metrics. So we have deployed ANN into Flask framework. So we'll be executing the project using Flask web application. So before execution, first we need to open the code folder which contains the project source code files. So this is the code folder and these are the contents I have in the code folder. This is static folder. So this folder consists of files related to CSS, JavaScript, and Bootstrap files. This is templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. These are model files which contain algorithm information. So these files will be loaded into the project code during runtime to utilize the trained models. This is app.py file. So this .py file contains the information related to front-end logic. It includes coded in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. And this is also a model file. This is the dataset file which contains the required dataset. So this is the dataset. This dataset contains network traffic data with fields like source, destination, packet count, byte count, duration, protocol, and various metrics to classify traffic as benign or malicious. So we will be using this data to train the deep learning models. So before training the models, we have performed some pre-processing steps to this data, and we have stored the pre-processed data in this file, data underscore processed. This is notebook Jupyter source file, which contains a combination of code, graphs, and outputs all in one place. So it allows users to write and execute code in individual cells, making it a popular choice for data science. This is test cases file in which I have test cases. This is signup.db file. This file is the database file used to store user information. So this is about the code folder. Now copy the path of the code folder from the address bar of the file explorer. This is the path, I'm copying it. Open Anaconda prompt. Use the command cd followed by a space and paste the copied path and hit the enter button. So this command is used to change the current directory to the code folder's path. Now compile the app.py file using the command python space app.py. I'm typing python space app.py and hit the enter button. So this command executes the Python script and performs a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address localhost and port unless configured differently. Now copy the local link provided by the framework. I'm copying it and paste it into any web browser. I usually prefer Chrome. I'm pasting it here and hit the enter button. So the home page of the project has been displayed in the browser. This is the front end built using Flask framework. Here we can see a sign up link, click on it. So if we are new users, we have to register ourselves first, fill in all these details and click on register button to sign up. And if we already have an account, we can directly log in by clicking on the sign in link. So as I'm already a member, I have clicked on the sign in link and I have to enter the username and password here. Give the credentials and click on login button. So it has redirected us to the predictions page. So now we have to fill in these parameters and click on submit button to get the classifications whether benign or malicious. First we'll understand these parameters. The first parameter is switch. So it is the identifier for the network switch handling the traffic. Source is the IP address of the source device sending the packets. Destination is the IP address of the destination device receiving the packets. Packet count is the total number of packets sent in the flow. Byte count is the total number of bytes transferred in the flow. Coming to protocol, it is the type of protocol used for the communication. Example TCP, UDP. Flows is the number of distant flows observed in the traffic. DT is the unique identifier or timestamp for the data record. Total duration is the total time duration for the flow in nanoseconds. Coming to duration, it is the duration of the flow in seconds. Packet rate is the rate of packets transmitted per second. Packet per flow is the average number of packets per flow. Byte per flow is the average number of bytes per flow. Pair flow is the whether the flow is part of a paired flow that is bidirectional. Coming to port number, it is the port number used for the communication. TX bytes represents total bytes transmitted from the source. RX bytes represents total bytes received by the source. TX kbps is the transmission rate in kilobytes per second and RX kbps is the reception rate in kilobytes per second. So this is about the parameters. Now we'll fill in these parameters. I have entered the parameters. Now click on submit button. So here we can see the outcome, the classification, that is benign or traffic is normal. So according to the given set of parameters, the application has classified the traffic type as benign, that is normal. Click on try again. We'll try giving another set of parameters. I have entered the parameters. Now click on submit button. So here we can see the result, that is malicious or traffic is not normal. So the application has classified the traffic as malicious, that it is not normal according to the given set of parameters. Click on try again. We'll try giving another set of parameters. I have entered these parameters. Now click on submit button. So here we can see the classification. So according to the given set of parameters, the application has classified it as malicious or traffic is not normal. So in this way, we have to enter the parameters, click on the submit button and get the classifications. Click on try again. We'll try giving another set of parameters. These are the parameters I have entered. Now click on submit button. So here we can see the classification, that is benign or traffic is normal. So according to the given set of parameters, the application has classified it as benign or traffic is normal. Click on try again. We'll try with one last case. These are the parameters I have entered. Now click on submit button. So here we can see the result, that is benign or traffic is normal. So according to the given set of parameters, the application has classified it as benign. So now click on logout. So in this way, we have to enter the parameters and get the results, the classifications, if the traffic is benign or malicious. So this project employs deep learning to develop an effective DOS detection system for classifying network traffic as benign or malicious. By addressing limitations of traditional methods, it enhances network security, reliability, and performance, benefiting administrators, organizations, and end users alike.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.